Yes, good morning. Today we are in the previous video, few properties we have done. That was the idempotent law we have completed, then identity property I told, then the commutative property I told. Now we are coming on associative property. What it says that if A, B, C are three sets, then if you take A and B union first, and whatever result comes in its union with C, or you do one thing, first you take B and C union and then you take union with A, the result come out to be same. This is called the associative property for the three sets A, B, C, associative property for union. So this bracket can change easily. Same way if I say A intersection B intersection C. This is same as A intersection B intersection C. In intersection also we can do the same thing. A and B intersection first you take, in that you take intersection with C, and here we will say A, B intersection C first and then intersection you take. This is coming same. So bracket or the pairing of sets you can change, result is not going to change. This is both union here, both intersection here. So this property we called as associative property. Second property, this proof you can prove yourself, and we are not going to ask these some proofs which are difficult one or which are new one for us, that we do. Distributive property. In distributive property, if you remember, you have done this real number. When you have done, then you have done this is A into B plus C. It will be AB plus AC. You have done this. A first multiply with B plus then A multiply with C. This is called distribution of multiplication over addition. This we have already done. Now this will be also coming in sets. Now what this set says, that if you have A union B intersection C. Just check here, this is multiplication and addition. Here we have union and intersection. When you have this, then the distributive property says first A union B. First A operated with first one with the union. Then this operation will remain as it is, intersection. Then this again going to operate with C. So A union C. This is called distributive property, distribution of union over intersection. Associative, we have done both union, both intersection. But here one is union, another is intersection. This is union, this is intersection. So it is called distribution of union over intersection. Same way when we say A intersection B union C. When I say A intersection, now this is called distribution of intersection over union. Then what result will come? It will come A intersection B union A intersection C. This is called the distributive property of union over intersection or intersection over union. So this way you can have the distributive property. Then we have another very important one. This proof I'll be doing, De Morgan's law. This is entirely new for you. Next one is De Morgan's law. What De Morgan law says, now we want this to be taken now. De Morgan law says that if you take A union B and take the complement on total, A union B whole complement, this will be equal to, now in this case, if this complement I'll take on individual, that is A dash, and on this it is B dash, then this union will change to intersection. By the way, if it is A intersection B whole complement, then again if dash is going to go on individual, this intersection will change to union. So A union B whole complement is equal to A complement intersection B dash or B complement. Here it comes A intersection B complement is equal to A complement union B complement. So keep in mind, if dash goes on individual, union will change to intersection. Or you go other way, that if I want this complement should go on total, then intersection will change to union. So this is called De Morgan's law. Now I'll prove one part. Second, you can try yourself. So I'll start with the first one. I have to prove A union B whole complement is equal to A complement intersection B complement. So what I have to show, this will be subset of this and this will be subset of this. To get this, how to do? Just check. We start with this first left hand side. Let X is an element of A union B whole complement. X is an element of A union B whole complement. Now one thing you should remember, if X is belonging to A complement, this is your Venn diagram, mu and this is A. If someone say X belongs to A complement means except A we have the answer. So this shows X does not belongs to A. If X is in complement, that means it cannot belongs to A. So here in this case, what I say, X is an element of A union B whole complement. What does it mean? This implies X does not belongs to A union B. Be careful what I am doing now. This will be helpful in your questions also. How to prove this? So X does not belongs to A union B. If it is in complement, that means it cannot be in A union B. Actually, A union B complement is this. This is A, this is B. A union B is this, so A union B complement will be this portion. So if X is a member from here, it cannot be in A union B. Now, if X is not in A union B, this is A, this is B. X is not here. If it is not here means it cannot be in A, it cannot be in B. Because if any one of them it is there, or in both if it is there, it will be in union. So here we will say X does not belongs to A and X does not belongs to B. X does not belongs to A and X does not belongs to B. If X is not in A, if not in A, where it should be? It should be in complement. So I should say this implies X belongs to A dash and X belongs to, and if it is not in B, it will be in B complement. And now AND is here. AND means the intersection here. So I should say X belongs to A dash intersection B dash. Now what you got? X was the element of this, is now present here. Means all the elements of this are here. What does it mean? This implies A union B whole complement will be a subset of A dash intersection B dash. This is the first condition. Now I go with the other way, second side. Second side means I'll take with this. X belongs to A dash intersection B dash. What does it mean? This implies X belongs to A dash and X belongs to B dash. If X in A dash means it cannot be in A. And at the same time, if it is in B dash, it means it cannot be in B. If X is not in A, not in B, if X is not in A and B, any one of the two, if it is not here in any one of them, means it cannot be in union. So we will say X does not belongs to A union B. And if it is not in union, where it will go? X belongs to A union B whole complement. So here X belongs to A union B complement means this will be subset of this. So what does it mean? A dash intersection B dash is a subset of A union B whole complement. This is equation 2. By equation 1 and 2, this is subset of this is subset of this. So by equation 1 and 2, what I get? A dash intersection B dash is A union B whole complement. Hence proved. This is our De Morgan's law. So one part I have proved. Second one you can try, but that you try. Before that, I'll just revise certain things which you will find slight difficult. So I just revise that also, and you note it that you should use it. Now, first thing which we should keep in mind, if X is an element of A union B. This is a brief revision of whatever we have done in the previous case. X is an element of A union B, then I told X should be an element of A or X is an element of B. This is A, this is B. A union B means this part. So X belongs to A union B means this. If someone say X is not an element of A union B, if it is not in this case, then what change will be here? We will say X is not in A and it is not in B. It cannot be here, it cannot be here. So neither in A nor in B it will be. So X does not belongs to A union B means this condition comes. So one result you should remember this. Second result is X belongs to A intersection B. This is A and B. Intersection is this. If someone says X belongs to A intersection B, so X belongs to A and X belongs to B. We are taking those elements which are in A and B both. But if someone says X is not an element of A intersection B, it is not here, means either it will be in A, somewhere here, or it will be somewhere here, or nowhere, or gone outside. So we will say it implies X is not in A, because by the way element is coming here, it will not be in A. If it is here, it will not be in B. And if it is here, it will be neither in A nor in B. So X does not belong to A or X does not belong to B. So either not in A or not in B or not in both. So that also you should keep in mind. Negative whenever intersection, it will become OR. It was AND, it will convert to OR. In union also I told you. Third condition, I told that if it is A and if I say X belongs to A complement means here. That means we should keep in mind X does not belongs to A. Or if you say X does not belongs to A, what does it mean? X belongs to A complement. So these are the results we should remember. Clear? One more result they can ask. A minus B. We have done that also. This is A, B. This is A minus B. So if someone says X belongs to A minus B, what does it mean? X belongs to A and X does not belongs to B. X is a member of A but not a member of B. So that element which are of A but not shared by B will not be taken here. So X belongs to A minus B means X belongs to A and X does not belongs to B. If it is B minus A, then what you should say, X belongs to B and X does not belongs to B. So these are very important results you should remember and please do it. And from this, it will be easier to solve the questions. Thank you.